Welcome everybody. Thank you for attending today. My name is Christopher Guy. I'm the Chief Executive of Tilted UK and Ireland, a position that I've had the privilege to hold since January 2020. My special thanks go to Dr. Lisa Cameron, the MP for East Kilbride, Strathaven and Medmenhago, for giving her time and supporting our virtual launch today. It's fantastic to have the Minister take time out of her busy calendar to join us at the beginning of our new journey. As a background, Tilted has been in the constituency since 2001, when acquiring the UK National Engineering Laboratory, a research and development facility that has been in East Kilbride for over 60 years. I'm pleased to say we have been continuing the strong scientific focus there, required by us as the UK's designated Institute for Flow and Density, part of the national measurement system funded by BEIS. The recent opening of the Advanced Multi-Phase Flow Facility at the site in October 2019 shows our continued commitment to the region and the importance of significant investment to develop and improve our physical national measurement standards that provide the UK's national flow measurement traceability. As an international organisation, though, our origins are from over 150 years ago, when they came about because of some safety concerns on steam boilers. Or more pertinently to today's topic, the power of steam, not the power of hydrogen yet. Since that time, our organisation has been through 3 technological revolutions. So today we face new but somewhat familiar challenges. As the world considers our impact on the planet through climate change, resource scarcity, and how we redefine that safety definition, we're evolving our experience and our expertise and our service offerings to enable customers to address decarbonisation, sustainability, and cybersecurity, to name a few. With that in mind, I'm very pleased to see us announce today a major milestone on that energy decarbonisation journey, the UK's first traceable hydrogen flow calibration facility for domestic gas meters. To talk you through what that means, I'd like to hand over to my colleague Martin Hampton to explain further. Thank you, Martin.
Thanks, Chris, for the nice introduction. Indeed, the journey to net zero has begun in earnest, and as the Committee on Climate Change have highlighted, we will need all of the tools in the box to achieve it. It's pretty clear now that hydrogen is widely viewed as a key part of that solution to achieving climate neutrality, as it has the ability to provide energy solutions that are complementary to direct electrification. In essence, hydrogen can reach parts of the energy system that other vectors cannot. So it's for this reason that there's a significant interest in the use of hydrogen for the transport and storage of energy, and for end users such as heating, mobility and industry. As the UK's designated Institute for Flow and Density, we identified that accurate flow measurement will be crucial to enabling a hydrogen economy. This is because whether used as a liquid or a gas, or converted to a hydrogen carrier such as ammonia, hydrogen will change hands numerous times as it moves through that integrated energy system. And each time it changes hands, the amount being sold will be determined by a flow measurement. Hence, flow meters will be the cash registers of a hydrogen economy, much as they are for oil, gas, petrol and diesel today. One of the most rapidly emerging needs in this new hydrogen economy relates to the gas network, where numerous projects are currently underway with a view to converting that network from natural gas to hydrogen. 2 different options are being considered: blending of hydrogen with natural gas and complete conversion to hydrogen. But the key thing is that in either of those scenarios, essential work is needed to make sure that both the existing gas meter stock in the UK and any newly developed smart meters specifically for use with hydrogen, they need to be leak tight, and we need to make sure that they measure with sufficient accuracy to comply with the relevant regulations. So it's for this reason that we've built this new facility, funded by BEIS kindly through the National Measurement System mechanism. we have a busy programme of work over the next couple of years through our involvement in several EU metrology research projects, our own national measurement system R&D work, and contract work for UK gas network demonstration projects. In fact, I'm very pleased to say that the first work has just started on the facility, and we're testing domestic gas meters for the High Deploy project, which is blending 20% by volume hydrogen into the gas network. So in addition to meeting the immediate R&D needs to ensure suitable gas meters are available, the facility will also provide ongoing measurement traceability for the UK for this particular application. So without further ado, it's my pleasure to hand over to Dr. Lisa Cameron, our local MP. So Lisa, please.
Oh, thank you so much, Martin, and everybody. Good afternoon, everybody, and it is truly wonderful to be here virtually today, opening this world-leading facility, which represents an absolutely vital step towards the goal of making hydrogen a key pillar within our sustainable future. Today launches the UK's first traceable hydrogen flow calibration facility for domestic gas meters. The new facility will help meter manufacturers determine if existing meter stock and new technologies under development are correctly measuring hydrogen flow rates. This is an absolutely crucial task to ensure that hydrogen gas meters deployed onto the market in the future will deliver accurate measurements for customer billing and for taxation purposes. So can I firstly thank TÜV SÜD not only for the vital work that they do through our facility, but also for all that they bring to modern and innovative solutions to all corners of our lives. Investment in Kilbride and the carrying on of this research legacy of our town goes as far back as 1947, when Government Research Laboratory was built here. As someone who grew up here very proudly and who is privileged enough to represent our town in Parliament, this is a legacy we are rightly extremely proud of, and one we are excited to take forward in partnership with TÜV SÜD, Scottish and UK governments. It feels really appropriate to me that COP26, due to be held later this year in Glasgow, should take place not far from our facility. It will stand as a testament to all of the delegations attending this important conference that hydrogen must play a pivotal role in our global effort to reach net zero. So to my mind, there is much potential for expanding the role of hydrogen as a clean energy alternative. And in opening this facility here today, TÜV SÜD is signalling to the world that East Kilbride will be at the forefront of global efforts to explore hydrogen's potential and the role it could play in combating climate change, one of our main priorities for years to come. The UK government has committed to the publication of our hydrogen strategy in 2021 this year, and working together we will accomplish much. In Parliament, I have every intention of pursuing my work as Vice Chair of the Hydrogen All-Party Parliamentary Group to ensure that our strategy is published and takes us forward in partnership, including with our constituency towards these goals. So I'm delighted that in opening our facility, East Kilbride will be a driving force within this effort. My priority is, as always, to our constituency and to your work and workforce to ensure we are at the centre of innovation and at the heart of the fight against climate change. Our workforce is second to none, highly skilled. In fact, I went to school with many of you without disclosing my age. But this excellent centre should be held up as an example to all that can be achieved when international business meets a dedicated and highly skilled community such as ours and works in partnership with government at all levels. I was so very impressed during my last 2 tours of the facilities, and I'm always keen to have the opportunity to meet with staff and see this progress. So I do hope to be with you in person as restrictions lessen over the coming year and to see firsthand the fantastic work that's going ahead. You have my full support in your crucial work, And can I offer my absolute thanks on behalf of our constituency for the fantastic developments here being launched today at TÜV Süd, and for their research, their innovation, their investment into our constituency and into the UK, ensuring that we are situated at the very heart of green innovation now and for many, many years to come. Thank you so much.
Okay, thank you, Dr. Cameron, for those inspiring words and for your support with this opening event. I think we've had an excellent overview of the role of hydrogen in the energy transition, as well as our role in providing measurement traceability. So I'm just going to finish this off by briefly talking about the facility capabilities and the range of some of the activities we'll be involved in the coming months. So as Martin previously said, there's two approaches that are being pursued in the UK in terms of using pure hydrogen or hydrogen as a blend with natural gas and within the gas networks. Our first project is looking at testing of meters with up to 20% hydrogen, but I'm pleased to say that we can also test with pure hydrogen as well. We have two reference sections, one for hydrogen and one for natural gas. So we can establish mixtures of anywhere between 0 and 100%, which means that we're very well placed to support these ongoing UK demonstration projects, but also manufacturers who are looking to develop new flow meter technologies. The work that we're doing isn't just limited to the UK, however. We are involved in various European funded projects, including the NPR funded New Gas Met project, also known as flow metering of renewable gases. And within that project, we are collaborating with various European measurement institutes in an experimental program, and also working on the revision of the CEN TC237 standards for domestic gas meters, which are used as the basis for legal metrology within Europe and the UK. Finally, I just want to say that although this facility is designed for domestic gas meters, it can operate across a wider range of pressures and flow rates, which really opens up the range of technologies that can be tested within it. So we have some upcoming work planned for higher flow rates and higher pressures, which will mean that we get to really evaluate the performance of the types of meter technologies that are likely to be used in larger industry applications and within the gas networks, more towards the distribution and transmission scales, which should really provide useful insights to the gas network itself. So I could go on more about the technical detail, but we have this summarised in a facility data sheet that is available online, so I won't go into too much detail on part numbers at this point. But thank you everyone for your overview of this subject and for the support in opening this facility.
Okay, great. Thanks, Mark, for that overview and of the facility and upcoming work that we have. So just to close things out, I would also like to extend my thanks to the whole Clean Fuels team at NEL, working with Mark, who have worked to design, oversee the build and conduct the commissioning of this first of a kind facility in a way that's gone very smoothly. And I look forward to seeing the first results being produced in the near future. All that remains is for me to extend a final thanks to both Chris and Lisa for their time and support today, our marketing team for their support in this launch, and finally to BEIS for their continued support of us as part of the National Measurement System and for funding this facility through that National Measurement System mechanism. So with that, farewell and thank you.